Hello everyone, I welcome you all to JK Tech Solution YouTube channel. Today in our channel, I am going to walk you through the spherical capacitor design using ANSYS Maxwell. So let's start our session. So before getting into the simulation, we need to know the formula for spherical capacitor. So the formula for spherical capacitor is C equal to 4 pi epsilon r into AB divided by B minus A. Here, as you can see in the image, in the spherical capacitor, the inner sphere radius is A and the outer sphere radius is B. In the inner sphere, it is surrounded by positive charge. It is having positive charge. Okay. In the outer sphere, we are giving negative charge. Okay. So that is what the formula. So these are all the design parameters we need to consider for designing a spherical capacitor. So dielectric constant is 4.4. We have taken here as FR for epoxy epsilon r, which is equal to 4.4, and the inner radius A equal to 10 millimeter, and then the outer radius B equal to 20 millimeter. So these are all the design parameters we have taken for designing a spherical capacitor. So this is what a manual calculation I have done for designing a spherical capacitor. So to verify the answer in ANSYS Maxwell. So as you can see here, epsilon or FR for epoxy is 4.4 and the inner radius A is equal to 10 millimeter. I have written here in SI units, that is meter, which is equal to 10 into 10 power or minus 3 meter. And similarly, I have written for outer radius, which is B, which is equal to 20 millimeter, which is 20 into 10 power minus 3 meter. So I have substituted these inner radius, outer radius, as well as the epsilon naught and epsilon naught values in the spherical capacitor formula. So after substituting, I am getting the value as 9.7861 into 10 power minus 12. Okay, it's 10 power, as you all know, 10 power minus 12 is nothing but picofarad. So hence C equal to 9.7861 picofarad. So this is what a value I get. So let's we enter into ANSYS Maxwell simulation part. So as you can see here, this is as we open ANSYS Maxwell. So here, after getting into ANSYS Electronic Desktop Student, you need to click on Maxwell. After clicking Maxwell, it will load. So I have clicked on ANSYS Maxwell. Okay, so the screen have. So after clicking ANSYS Maxwell, you need to click on Maxwell 3D. Okay, so you need to click Maxwell 3D in the title bar. The Maxwell 3D, you need to select solution type. The solution type you need to give electrostatic. Then click OK. So after giving electrostatic, we just start our design. So you need to click on sphere. As we are designing spherical capacitor, you need to click on sphere, and then you need to click on the center part of axis. And so we have drawn the sphere. The next you need to just give Control C, copy, and then we draw another sphere. It is inner sphere. Okay. So we just need to rename it. So as I clicking sphere 1 and I'm renaming it as outer sphere. And then next in the sphere 2, I renaming it as inner sphere. So after renaming outer and inner sphere, we need to assign material for this sphere. Okay, for that I'm just clicking on here vacuum, right click, properties. Here you need to give the material as FR for epoxy, as we have discussed in the manual calculation. We are given the FR for epoxy whose relative permittivity is 4.4. So I am here giving FR for epoxy and just give OK. So here we have to give the inner radius and outer radius. As we all know, outer sphere we have given the radius is 20 millimeter. So outer sphere radius is 20 millimeter. Just give apply, then OK. For inner sphere we have given 10 millimeter. The design parameters we have told we need to assign 10 millimeter. So inner sphere I have assigned 10 millimeter and outer sphere I have assigned 20 millimeter. Now just give fit all. So as you can see here, outer sphere, this is what outer sphere, and then inner sphere. So you can see both outer and inner sphere. If you wish, you can also change the color of both outer and inner sphere. So for I am giving for outer sphere on color. For outer sphere, I am giving green color. Okay, so it's your wish. You can give any color. We can able to differentiate easily. For that, I have given. The next, we need to subtract both outer and inner sphere. So for subtracting outer and inner sphere, you need to click on control and then first click outer sphere and then click inner sphere. Give the option subtract. So in the blank part, you need to enter outer sphere. In the tool part, you need to have inner sphere. Then just give OK. So after subtracting, we need to give an option called split. For that, again, you need to give control outer sphere, then inner sphere. There is an option called split. Okay, you can find the split option in the menu bar. Okay, so in the menu bar, you can find split option. Just give the split. So after giving split, you will be getting here a split using plane XY. Then positive side, split all selector objects, delete invalid objects created during operation. Then just give OK. So we need to assign voltage. Our next step is to assign voltage. Orientation, you can view a trimetric view, fit all. So here what I'm going to give here. So just give right click in the mouse and then selected mode will be phase. Okay. So in the inner sphere you need to assign excitation, voltage. In the inner sphere you need to assign the voltages 1 volt. And then as you can see in the project manager, we have assigned for inner sphere 1 voltage. Next, we need to assign a voltage for outer sphere. For outer sphere, I am clicking assign excitation, voltage 0 volt. Okay. So as we already discussed, the inner sphere we have a positive charge, and outer sphere we have a negative charge. So in the outer sphere, I am assigning the voltages 0 volt. So after assigning the voltage, just give trimetric view so that we can see clearly. As you can see in the voltage 1, we have assigned our value. In the voltage 2 also, we have given the excitation. The next part we need to do here is parameters. Click parameters. Here you need to give assign. Here matrix, voltage 1, voltage 2. And just give OK. The next part we need to do here is analysis. So for analysis, just give add solution setup. Then give OK. So we have done analysis setup here. Okay. Next we need to check validation check or step validation check. So our all parameters are satisfied. As you can see, we have a green tick mark here. So our design is correct. Now you need to give analyze all. So before giving analyze all, we need to save the file. It will ask for saving the file. I am assigning the file name as spherical capacitor. Spherical capacitor 24. Okay, just give save. So now our analysis part will start. Okay, as you can see here in the show progress, as you can see here, our analysis part have started. It will take 32 seconds to 1 minute. Okay, we need to wait for that. Now our progress have been completed, our analysis have been completed. Now in the title bar, you can find Maxwell 3D. You need to click on Maxwell 3D. Here you need to give results. The result, create electrostatic report, data table. Click on data table. C, okay, C is certified capacitance. Okay, so give new report in matrix 1. You need to click on new report. So as you can see here, we have obtained the value as 9.26, sorry, 9.296369 picofarad. Okay, so here they have given the value in picofarad. So what we calculated, this is what our simulator calculated value, that is 9.296369. As you can see, our manual calculation. So here we have obtained a manual calculation 9.7861. Nearly the both values what we obtained in Maxwell as well as the manually calculated value are same. Hence we have successfully verified both the values in simulator as well as manual calculation. So our session have completed. So thank you so much for patiently watching this video. I hope you to see you again on next video. Thank you. Have a nice day.